Okay, this is the P3 paper from June 2021. This is the first question, question number 1, and we're going to be doing some differentiation work because we want to find the stationary point, so we need to differentiate, and we've got a product in here. And then after that, we can see we've got some numerical methods. We're going to be doing some work on fixed point iteration. Okay, so let's look at this. It says the curve has a stationary point at the point P. Show by using calculus the x coordinate. And it's a solution of that equation. We'll come back to that in a minute, but remember we've got arctan there, so that's a little bit of a clue. But for the stationary point, what we need to do is differentiate and put it equal to 0. So we've got that y is x squared cos a half x. So as I said, using the product rule, we're going to assign u to be equal to x squared, and we're going to make v equal to cos a half x. And then differentiating those, du by dx is nice and simple. That's just 2x. And you need to be able to differentiate something like cos a half x. So the way to think about it is that the differential of cos is minus sine, but this half is going to have an impact on it as well. So it's going to work out to be minus a half and then sine a half x. You really need to go and practice those away from past papers if you can't do that straight away at the moment. Okay, dy by dx, the differential then, we're using product rule, which is u dv by dx plus v du by dx. I always write it down every single time I use it. Just means that it gets concrete into my head as to the formula. And also it means that I hopefully shouldn't make any mistakes with my copying errors. So u dv dx is those two. So tidying that up, I'm going to write minus x squared over 2 sine a half x. That's the first term, plus those two. And again, I'm going to put the 2x first here, is going to be 2x cos a half x. Look at it beforehand and just make it the easiest way of writing that down. So that's dy by dx. I've told you, I now need to tell the examiner for stationary points, we have dy by dx equals 0. So we're going to have all of that thing equals 0. Okay, minus x squared over 2 sine a half x plus 2x cos a half x equals 0. And now sort of, it's in my mind already, go back and just remember what we're trying to get it to. Something involving arctan. Yeah, and arctan, well, tan is sine over cos. So I can see the first thing that I would do is I'd factorize and take x out of this thing to leave me minus x over 2 sine a half x plus 2 cos a half x equals 0. So we either get x equals 0, which we know isn't what we want, or this other bit here, minus x over 2 sine a half x plus 2 cos a half x, equals 0. I was thinking about that one in there. Yeah, so it's not the left-hand one, it's going to be the right-hand one then, and we need to try and solve this now. So all I'm going to do is I'm going to say 2 cos a half x is equal to x over 2 sine a half x. In effect, I've just taken that over to the other side there. And now simply because the answer set involves arctan, I'm going to get sine over cos. So if I get sine over cos, I'm going to take that thing down there, which means I need to move this over to the other side. And so that's going to be the 2 going up and the x coming down. So quite a bit of work in this next little bit. That's going to be 2 times 2 is 4 over x there on the left-hand side. But on the right-hand side, we just have sine a half x over cos a half x. And the whole point of doing that was to then say that's tan, isn't it? So I've got tan a half x equals 4 over x now. And so if I want that, then 4 over x is, half x, around half x is going to be tan to the minus 1, or arctan 4 over x there, and we're nearly at what we wanted, so x is just going to be 2 arctan 4 over x, and wow, look at how quickly then we actually managed to get to what we were looking at. And notice I particularly in this one wasn't aiming at that all the way through. I was really more aiming at just trying to get sine over cos, and then the rest of it sort of came out naturally without me having to do too much work for it. That was a relief. Okay, B. What does B ask us for? So we now have a bit of a change of topic here. Now that we've done that, in effect, we've derived an iterative formula, and it's now going to ask us just to use the iterative formula. So here's a formula. We're going to be starting with x1 equals 2. And what they quite often ask in the exam is they'll ask you for the first value, and then they'll ask you for a value after 3 or 4 iterations of it. I'll show you the way that I set these out then. It's entirely up to you what you do. It's 3 marks. So if we're doing this, what I would do is I would say, first of all, I'm going to write down the formula. X to the n plus 1 is 2 arctan 4 over x to the n. And then I say x1 is equal to 2, and I say x2 is equal to, and I basically just show myself putting the 2 in here. So that's going to be 2 arctan 4 over 2 here, which is 2 arctan 2, which then works out to be a value, in this case 2.214. They asked for 3 decimal places, so I've given it to 3 decimal places. For the rest of it, I'm not now going to say x3 is 4 divided by 2.214, and then the next, it just takes too long. So this is only worth 3 marks. I think they just want me to substitute the values back in now. So in order to get x3, I'm going to put this number in here and get an answer out. When I get that answer, I put that answer back in to get the subsequent answers. You know how to do iteration, hopefully. So x3 works out to be 2.130. It's more than that, but that's all I'm going to write down from my calculator display. Put x3 in, and x4 works out to be 2.163. And again, I'm only writing down to 3 decimal places, but I'm carrying over the whole number on my calculator. x5, plug that one back in again, 2.150. And then x6, which is the one that they want, works out to be 2.155. All of them corrected to 3 decimal places, but all of them using the exact values on the calculator. So that would be the way that I would lay out that second part there. Very systematic. Show the formula, show it working once, and then just go through to do the answers for those ones. Okay, if you think about it, that's worth a mark and that's worth a mark. It's only worth 3 in total. So you don't need loads and loads of method mark there to be able to get it. Okay, hopefully that makes sense.